All right, 7.2, use the converse of the Pythagorean theorem. All right, going back to chapter 2, what does converse mean? Remember, it's the flip of what we had before. So yesterday when we did 7.1, we talked about if you have a right triangle, if you have a right triangle, then a squared plus b squared equals c squared. Today we're going to flip it and say if a squared plus b squared equals c squared, then you have a right triangle. So we actually don't know if we have a right triangle, but we're going to check it with the Pythagorean theorem, okay? So that's our flip today, the converse, and that's what we're going to use, and we're going to still use the Pythagorean theorem, but now it's to check if we have a right triangle, not because we know we have it. Okay, so the first one, notice 3 sides of the triangle. It appears maybe there's a right angle, but it's not marked, and we can never, ever, ever assume it's a right triangle if it's not marked, okay? So we're going to check it. Now, the question always is, even with Pythagorean theorem, which one is your C? And your C is always your biggest. I have a 6, a 9, and a 3 square root of 13. Well, how big is 3 square root of 13? Well, I can always type it in my calculator, 3 square root of 13, and I get about 10.8-ish. I really don't need to know because here's the thing. I don't want to use this 10.8 in my math, but I kind of need to know it equals 10.8 because I know it's the biggest side, so that's going to have to be my C. So in for C squared, I'm going to put 3 square root of 13. In for A, doesn't really matter, right? But I need to choose 2 of them. So I'm going to put 6 in one spot and 9 in the other. Okay, 9 squared is 81. 6 squared is 36. Yep, I saved this for last. What does it mean to square something? It means to take it times itself, right? Which means I multiply the outside numbers together, which means I multiply the inside numbers together, okay? So 3 squared is 9. Square root of 13, remember those two cancel each other, and we get 13, okay? I often will just show this little like rainbow, and I'll say 3 squared is 9, square root of 13 is 13. I don't always do this side thing, but remember when you square a radical with a number on the outside, you have to square the outside number, you have to square the inside number, okay? By the way, if you square the inside number, you'll get like 169. Then when you take the square root, you still come back to 13. So if you learn it just cancels, it saves you some work. All right, where were we? 9 times 13. Calculator, 117. What's 36 plus 81? 117. They are exactly equal, and because they are exactly equal, we're going to say yes, it is a right triangle. Okay, so let's check B. All whole numbers, which is nice, and so which one has to be my C? The biggest one, so we're going to plug in 29 for my C spot. And it doesn't matter which is the other two, as long as we just put them there. I guess I could put the equal sign in the other spot, couldn't I? All right, so I get a 24 on one, a 16 on the other. Let's do the math. 29 squared. 29 times 29, 841. 24 squared. 24 times 24, 576. 16 squared. 16 times 16 is 256. All right, let's add 576 plus 256. I get 832. Are they equal? Definitely not. And because this is not a right triangle. You have to be exactly equal for a squared, b squared equals c squared, or it's not a right triangle. All right, let's keep moving. Now, I will tell you that if we were in class and I had plenty of time, I do have an activity I like to do to kind of reinforce this, but one of those things we kind of lose when we can't always do all of our stuff in class. So I'm hoping that we someday will get to do some of those things and maybe reinforce a few of these things. So I have, if the square of the length of the longest side of a triangle is less than the sum of the squares of the lengths of the other two sides, then the triangle ABC is a blank triangle. So this is all about, and I'm going to stress this over and over. Every time I talk to you about this, I'm going to say this. This is all about the c squared. If the c squared is smaller than a squared plus b squared, notice it's not equal to, so we know it's not a right triangle. If c squared is smaller than a squared plus b squared, we are going to have an acute triangle. And remember, acute ones are small, right? So this triangle is acute if c squared is smaller. So c squared is smaller, okay? It's acute. Wow. Sorry about that. A lot of mess there. Okay. Try to make it look a little bit better. Okay. Second theorem says, if the square of the length of the longest side of the triangle is greater than the square of the length of the lengths of the other two sides, then the triangle is, and in this time I see the square, c squared is bigger than all the rest, it is obtuse, okay? So again, it's all about that c squared. If c squared is bigger than all the rest, it's obtuse, okay? A couple of things I want to state to you. It doesn't say c is smaller than the rest. It says c squared is smaller than the rest. It doesn't say c is greater than the rest. It says c squared is greater than the rest. So it's important that we plug it into that Pythagorean theorem and square everything before we make a decision. Okay. Now, I say that because as we go into these other problems, we have one more thing we need to stop and go back on when we learned back in Chapter 5. The first question to ask here is, can segments with lengths of 2.8, 3.2, and 4.2 form a triangle? This question we first learned about in Chapter 5. How do I remember if three lengths will even form a triangle? Okay? The rule is two sides need to add bigger, wow, let me make bigger than the third side. Okay, that's the rule. Two sides have to add up bigger than the third side. And if you remember from Chapter 5, we said we could check this all day long, but really you only need to check the two smallest, okay? So if you add up the two smallest and it's bigger, not equal to, but bigger than the third, we will be able to make a triangle. So I'm going to be honest, I'm not even going to check these two. I'm just going to add the two smallest, 2.8 plus 3.2. Well, that adds up to 6. Is 6 bigger than the third side? It is, so yes, it's a triangle, okay? So, by the way, you have to try that first. Now, quick note. We didn't square those sides. We simply looked at their measures and said the first two have to add up bigger than the third. That's all we did. Now, to check to see what kind of triangle it's going to be, obtuse or acute, now we need to square them. Okay, so I have three lengths, right? I have 2.8, 3.2, and 4.2. Which one would be my C? And I should have stated that up there on the top. Do you notice that in those boxes and those theorems, they never said the word hypotenuse? Because the only kind of triangle that has a hypotenuse is a right triangle. And we basically have said there's a good chance these are not right triangles. So they dropped the use of the word hypotenuse because it only goes with a right triangle. Okay, so they're just calling it the longest side and then the other two sides. But my C is my longest side. So I have these 2.8, 3.2, and 4.2. So my C has to be the longest one. So I put 4.2 in my C spot. I put the other two in the other two spots. It doesn't matter. And remember, this is where we use that calculator because 4.2 is not 16.4 when I square it. I need to do 4.2 times 4.2. Please leave it out to all the decimal places. So 4.2 squared, 17.64. 2.8 squared, 7.84. 3.2 squared, 10.2. Something's off on that one, isn't it? That is not 10.2. I just forgot to write the last number. 3.2 squared. How about 10.24? I just dropped my number. Okay. 17.64 is all by itself. I need to check the other two. 7.84 plus 10.24 is 18.08. Definitely not equal. Okay. So which side's bigger? The 18.08. This is what I need to remember. C squared's over here, and C squared is smaller. If C squared is smaller, then it means I have an acute triangle. Okay? C squared is smaller, it's acute. All right, let's try the next one. All right, real world problem, because I'm sure you've been dying to try this out. Okay, you're helping install a light pole in the parking lot. When the pole is positioned properly, it should be perpendicular to the pavement. How can you check that the pole is perpendicular using just a tape measure? Okay, because you haven't taken your right angle out with you. Okay, some of you that are in drafting know you have those nice T-squares, right, that show a right angle. Apparently you don't have that in your pocket, so all you have in your pocket is a tape measure. How could you show that you have a right, or your light pole is perpendicular to the ground? Okay, so this is what they're suggesting. Take your tape measure, measure 3 feet up, make a mark. Take your tape measure, go back to where you just started, and go out in your parking lot 4 feet and make a mark. Then join this mark to this mark and check, is it 5 feet? If it is, congratulations, you have a perpendicular because you have a 3, 4, 5 triangle. If it's not 5 feet, then you might not have 90 degrees. Okay? And it says don't only do it on one side. Maybe come out to the front and check it again. Come 4 feet this way. You keep checking from different sides to make sure it's 90 degrees all the way around. Let's just say if you're installing a light in the parking lot, maybe a right triangle wouldn't be a bad tool to have with you, just if that's your job. Just saying. Okay. So, quick note again. If you have a triangle, you only have 3 choices. You either have a right triangle, an acute triangle, or an obtuse triangle. Those are the 3 choices. So, if c squared equals a squared plus b squared, you have a right triangle. If c squared here is smaller than the other squares, you have an acute triangle. And if c squared is bigger than your other side squared, you have an obtuse triangle. You need to have those memorized. You need to remember that, okay? All right, one final page of notes. See if we can make this any harder, right? Okay, let's check these triangles to see, do I have a right triangle, an obtuse, or an acute? Okay, I know the directions only say is it a right, but we might as well go ahead and say what kind it is if it's not right. All right, so I'm thinking a squared plus b squared and c squared. But I always have to know which one goes in the c squared slot. It needs to be the larger one. Currently, 4, 5, and 2 square root of 10. How big is 2 square root of 10? 6.3-ish, okay? Now, here's the key. Don't put 6.3 in that formula. Just keep that in the back of your mind. The only reason I wanted that decimal was to see which side was bigger. So I know because 6.3 is bigger that this c is 2 square root of 10. Always, always, always leave that radical. Do you remember we call that our exact answer? We want that exact number in our formula. Don't plug in the decimal. A squared, I don't care. 4 in one spot, 5 in the other. Just make sure they go there. Okay. I should be careful in writing an equal because I don't know what it is. 4 squared is 16. 5 squared is 25. Okay, 2 square root of 10. Remember, the 2 gets squared. That's 4. The square root of 10 gets squared. That's 10. And I multiply them together. I get 40. What's 16 plus 25? 41. Ooh. 41 is bigger than 40. This is my c squared. If c squared is smaller than the rest, what kind of triangle do I have? This one is acute because c squared was smaller. All right, let's go to number 2 and try again. So I get an a squared, b squared, and c squared. I need to make sure I know which one's my c. 15 is definitely not. 18 might be. What is 3 square root of 61? 3 square root of 61 on my calculator is about 23.4. Remember, I don't want that number, but I just wanted to know if it was bigger. It definitely is, so that's my c. So in for my c spot, I'm putting 3 square root of 61. And 15 and 18 into my a and b spots. So 15 squared is 225. 18 squared is 324. And remember, when I square a radical, I square the first number. 3 squared is 9. Square root of 61 squared is just 61. I multiply 9 times 61. I get 549. 225 plus 324 is 549. They are equal. Anytime they are equal, that triangle is a right triangle. Okay? All right, moving on to number 3 here, some decimals. But I need to be careful, okay, because the very first question it says is, can the segments with these lengths form a triangle? So remember, back from our chapter 5, what we learned, take your two smallest ones, add them together. Is it bigger than 11.3? That's the question we're checking. Well, 6.1 plus 9.4 is 15.5. Is that bigger than 11.3? Yes, so that means we have a triangle. Now we want to find out what kind of triangle. Okay, so which one of those has to be my C? Well, C has to be my 11.3 because it's the largest. So A squared plus B squared and C squared. I put 11.3. I put 6.1. I put 9.4. Oh, definitely calculator work from here, right? I don't want to do these on my own. Okay, 6.1 squared, 37.21. 9.4 squared, 88.36. 11.3 squared, 127.69. Please don't round those decimals in your work because it will change your answer if you round too fast. All right, this one is 127.69. I'm going to add 37.21 plus 88.36, and I get 125.57. Which one is larger? This one is larger. Okay, so if this one is larger, which was my C squared, so if my C squared is larger, that is an obtuse triangle. Okay, so yes, it makes a triangle, and therefore it is obtuse after we do the work. Don't square things to check if it's a triangle, but you have to square things once you know it's a triangle to see if it's acute, right, or obtuse. All right, number 4, and then we're going to go do that margin one. Number 4 says, in example 3, could you use the triangle with sides 50, 120, and 130 to verify that you have a perpendicular line? So, if you had sides of 50, 120, and 130, does that prove perpendicular? Or, don't forget, right triangle, right? That's really what they're asking. So, let's check A squared plus B squared, C squared. Which one's the largest? 130. So we plug them in. Will this prove a right triangle? Well, 50 squared is 2,500. 120 squared is 14540. 13 squared, 16900. 2,500 plus 1,440 is 16,900. 16,900. They are equal. Does it prove a right triangle? Yes. It's a right triangle, right? Okay. Did anybody recognize that triangle? The 50, 120, 130, the 5, 12, 13 times 10. Remember, you don't have to memorize it, but if you did, it might have saved you all that work, and you could have said right away, yeah, I know that's going to work. Okay. The points A, B, and C form a triangle. Use math to decide if the triangle is right, acute, or obtuse. 3 ordered pairs. How am I going to be able to use 3 ordered pairs to tell if my triangle is acute, right, or obtuse? And I'm going to tell you right now, if I put this little direction in your quiz or test, that's what I want to see is some math. I don't want to just say, I graphed it and it looked like it. Nope, that's not going to work. I want to see some math. What kind of math am I looking for here? Aha, one of our favorites, distance formula. All right, we're going to find the distance formula from A to B. Remember, when I'm using the distance formula, I need my 2 ordered pairs, and they're going into my big formula. For those of you that don't remember, it is x2 minus x1 squared plus y2 minus y1 squared. That is on your formula sheet, hopefully, from chapter 1, 1.3. If it's not on your formula sheet, put it there, right? Okay, so that says I'm finding my second x, which is 7, and subtracting my first x, which is 4, and squaring it. Find my second x, which is negative 2, and subtract my first x, which is 1, and square it. Okay? Don't forget, it doesn't matter which is your first and second, as long as the x's go together and the y's go together. 7 minus 4 is 3. Negative 2 minus 1 is negative 3. All right. Please excuse my dear Aunt Sally said start with those parentheses. We did. Now we're going to do exponents. So 3 squared is 9. Negative 3 squared is 9. Do we ever get a negative in there? No, because negative 3 times negative 3 is positive 9. Now Aunt Sally told me to multiply or divide. I don't need to, but I can add or subtract next, which is going to give me 18. Now, I'm going to stress to you, just leave it. Don't touch. Okay? Just leave it. All right, now I want the next one. So let me go to this. I'm going to go to BC, which uses 7, negative 2, and 2, negative 4. And once again, subtract those x's, 2 minus 7 squared. Subtract those y's, negative 4 minus negative 2 squared. 2 minus 7 is negative 5. Negative 4 minus negative 2, that becomes a plus 2, makes it negative 2 squared. Negative 5 squared is 25. Negative 2 squared is 4. Never a positive, or never a negative out of that, right? And we're going to join that together, and I know that BC now is the square root of 29. And again, leave it. Don't worry about simplifying anything right now. Just go ahead and do that. All right, we have one more to go. What's my last side of the triangle? C to A. All right, C was 2, negative 4. A was 4, 1. Put it in my distance formula, so I get 4 minus 2 squared plus 1 minus negative 4 squared. 4 minus 2 is 2. 1 minus negative 4, add the opposite, so I get 5 squared. 2 squared is 4, 5 squared is 25, and I get another square root of 29. Okay, which is fine. Whoop, sorry. Okay, so I'm running out of space here, but I really want to show us what, square root of 29. Okay, the question asked, though, is this an acute, right, or obtuse triangle? Which means I need to check it with a squared, b squared, c squared, okay? So a squared plus b squared and c squared. By the way, which one of these has to be my c squared? I'm looking for which one's bigger. AB is a square root of 18, BC is a square root of 29, CA is a square root of 29. They're all in square root form, so we know when we get the decimals, the decimal that's biggest will come from the biggest square root. I have two that match, which means that one of them needs to be my C, okay? So I'm going to plug square root of 29 in for my C. I'm going to plug in the square root of 29 for my A and the square root of 18 for my B. Okay, this is what's beautiful about what we just did. If I take the square root of 29 and I square it, what do I get? 29. If I take the square root of 18 and I square it, what do I get? 18. If I take the square root of 29, what do I get? 29. Okay, so it's really nice to just leave them in those square roots, because then when I square them, it comes out nice. 29 plus 18 is 47. And of course we have 29. Which one's bigger? The 47. Remember that 29 was my C, which means my C was smaller than all the rest, which means this triangle is acute. Okay, because the C squared was smaller, I have an acute triangle. All right, that looks like a mess, but you know what? We got through it. And I'm going to just do this just to make things easier here. Okay, I'm going to come down here. My C squared is smaller, so that means my C is acute. Okay, I'm just going to write it down here so it's a little bit neater. Okay, you're in your book tonight, page 444. 4 through 22 even, 24 through 29 all. Once again, I stress this over and over. I need to see your Pythagorean theorems. I need to see a squared, b squared, c squared. Please do not write down right triangle, acute, obtuse, or something like that. I need to see the math. So please show me that work. And if you see one like this with ordered pairs, I need to see some distance formulas. Okay? If you have any questions, let me know.